Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. Now we discuss about the electric dipole and what is the electric field due to electric dipole at a axial point. So first of all, what is the definition of the electric dipole? What is the definition of the electric dipole? See the definition. The product of charge Q and distance between charges. How many charges? Two charges. Product of charge Q and distance between two charges is called electric dipole. So charge magnitude is Q. The distance between two charges, that is 2a. So finally, electric dipole equation P is equal to Q into 2a. So here small p represents or capital P represents electric dipole symbol. Next, so what is the structure of electric dipole? See here, we have two charges which is noted in definition of electric dipole. See here, minus Q and plus Q. These two charges are separated 2a distance. So why here enter 2a distance? Why we should not enter a? So that reason is minus q and plus q. These are different charges. These charges releases different direction of electric field lines. Different direction of electric field lines. These electric field lines are moving towards the charge. These electric field lines are moving away from the charge. So that's why these electric field lines are acted at midpoint of this dipole, and also positive charge dipoles. Positive charge electric field lines also acting at this point, from this point to this point. So the influence of minus q and plus q ended at midpoint. So at midpoint to minus q distance is A, at midpoint to plus q distance is A plus A, 2A. So that's why here mentioned 2A. So the electric dipole definition is product of magnitude of charge, either it is positive or negative, and distance between these two charges, that is 2A. So this is the electric dipole definition and equation Q into 2A. Based upon this electric dipole, which is placed at a electric field, which is placed at a electric field, at that field, this this electric dipole have an axial line. There is a any point on axial line. At that point, what is the electric field? What is the electric field? So next topic is electric field due to electric dipole at a point on the axial line. See that electric field due to an electric dipole at points on the axial line. You get that structure of the axial line and dipole. See here minus q plus q. The distance between these two charges is 2a. So that's why this is the electric dipole. This is the midpoint. From midpoint to minus q charge, the distance is a. From midpoint to plus q charge, that is a. So a plus a, 2a. And next, there is a point P from R distance. That means from O to P, origin point of the dipole to at point P, the distance is smaller. The distance between O to P, that is smaller. At P, there is a another charge. The force is applied on this charge. The force is applied on this charge. by the plus q and minus q. The force is applied on the point charge at a point P. This is the testing charge also. This is the testing charge. When the force is applied on this testing charge, this charge is entered in this electric field which is created by plus q and minus q. So here two distances are there, a that is to a distance between origin point to at a point P, that is small r, and distance between plus q charge 2 at point P, that is r minus a. See here, this total distance is r, remaining is a. So this distance equals to r minus a. Next, distance between minus q2 at point P, that is r plus a. So this is the information in this diagram. The axial line is this one. This is the axial line. So in this axial line, we consider the point P. So at this P, what is the electric field? By this electric dipole. So this is our concept. So let's go for the derivation for this concept. See here. We know very well the electric field formula E is equal to 1 by 4 pi epsilon naught Q divided by R square. Q is charge, R is the distance between point charge and testing charge. Distance between point charge and testing charge. Okay. Next one, next equation. Look at here the equation part. E1 is equal to 1 by 4 pi epsilon naught into Q divided by R minus A whole square. Why here entered Q divided by R minus A whole square? Coming to the positive charge. The electric field created by the positive charge, consider that is E1. E1 is equal to 1 by 4 pi epsilon naught into Q divided by R minus A. Why here enter R minus A? R represents here in normal electric field the distance between point charge and testing charge. Here the distance between point charge to testing charge, that is R minus A. So that's why here entering R minus A whole square. Coming to next charge, that is minus Q. The electric field created by minus Q is E2. By using this minus Q charge, by using the minus Q charge, we have another electric field E2 is equal to 1 by 4 pi epsilon naught into Q divided by R plus A whole square. So why here entered R plus A in before R minus A? So R minus A is the distance between positive charge to point P. R plus A is the distance between minus Q to point P. Okay, so that's why here entered R minus A, R plus A. Okay. Then the total electric field or resultant electric field E is equal to E1 minus E2. E1 minus E2. So there is a sum of these E1 and E2 electric fields. So this is the sum. So why here enter minus? Here E2 represents minus Q electric field. So that's why here minus is entered. So when you posted the E1 and E2 values here, we have a another relation. Separate the Q divided by 1, Q divided by 4 pi epsilon naught. So remaining terms are this. So after simplification, we got this relation. E is equal to Q divided by 4 pi epsilon naught into 4AR divided by R square minus E square whole square. Simplify this, definitely we get this. Coming to next point, R square is triple greater than A square. Why here R square is greater than when compared to the A square? See the diagram here, R is greater than when compared to A. So that's why here we're taking the value R square is very greater than when compared to A square. So that's why eliminate the A square term here. So remaining term is r square whole square, that is r power 4. So r power 4, I mean remaining one is r cube, cancel, r power 4 r cancel. So we know the electric dipole equation P is equal to Q into 2A. Separate this term to get these terms. Here Q into 2A, that is equal to electric dipole. So enter here, this is the electric dipole P. So the final result of the electric field due to a electric dipole at a point of axial. So finally, we get the relation V is equal to Q divided by 4 pi epsilon naught into 2P bar divided by R cube, Newton per Coulomb. This is the simple thing. So first of all, you have to write two different electric fields, E1 and E2, by using the distances R minus A and R plus A. So then you have to add these two, add these two equations. So then finally you get the relation. So at this relation, you have to put this part. So this part here you have to eliminate the a square value. So then you get the final equation. So this is the electric field due to a electric dipole at a axial line. Thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thanks again.